This is Mr. Swapnil Bapusaheb Herwade, the lecturer in Shri Institute of Technology, Polytechnic, Gatra, Vichalkaranji. I am here with the next lecture on chapter number 6, that is heat treatment process. Okay, we have already covered the first three chapters, and after covering the three chapters, we are directly gone to the chapter number 6 because we are just after seeing this whole six chapter, we will go to the fourth and fifth because those are the only theoretical ones. Okay, this chapter will consist some concepts. First we will see the concepts and then we will go to the fourth and fifth chapter. Okay, so the chapter number 6 is a heat treatment process, where these are the subtopics of our today's lecture. First is just a simple definition of what is heat treatment process, then the classification of heat treatment process, then purpose of heat treatment, application of heat treatment, and overview of the whole chapter you can see. Okay, so we will start with the definition. See, heat treatment process, it is an operation. It is an operation or combination of operation involving heating and cooling of a metal or alloy in a solid state to obtain desirable condition and properties. See, see in the diagram, okay, we have the three lines. In first line, this is a inclined line. We can see it as a heating. Okay. Just second, we have a constant line, or we can say it is a horizontal line. It is called soaking or holding. And third, declined line we have. It is called cooling line, or we can say controlled cooling. Okay. So these are the three lines. So these are the three operations we can say. Okay. So see here, what we are saying, that it is an operation. Okay, it may be a heating, it may be a holding, it may be a cooling, or what we are saying, operation or a combination of operations. Means it is a combination of heat treatment process, it is a combination of heating plus holding plus cooling. This whole process is called heat treatment process. Okay, see, this is a graph we can see on x-axis. On x-axis we have time, on y-axis we have the temperature. I mean, this is a graph for temperature and time. As we know, this is inclined line, means for heating purpose we must need some time. It should not be a vertical line. So heating of any material requires some time and it gains some specific temperature. Okay, so increase the temperature from room temperature to a certain temperature, we require some time period. So this is the inclined line. Okay, after that, holding means when we heat any material, okay, its temperature get increased, but the case that the temperature at the surface is more as compared to the temperature at the inner part. Okay, so holding period is given to make a material homogeneous with respect to temperature. Okay, or to make the material uniform with respect to the temperature. Means the temperature at the upper surface and the temperature at the inner body should be same. Okay, it is important to get a properties uniformly spread throughout the material so that it must be hold for a proper time period. Okay, there we cannot decrease the temperature. The holding process is done at a constant temperature. See, this is a horizontal lines, means the holding process is done for a constant temperature. Okay, just we are transferring the temperature from upper surface to the inner body surface so that we get a homogeneous material or we get a uniform material. Okay, and after that, third process is the cooling process. Okay, cooling can be done either in three or four types. We can cool the material in furnace, we can cool the material in air, we can cool the material in water. Means we have the three ways to cool the material. Okay, if I cool it in a furnace, we can call it as an annealing process. If we cool it in air, we can call it as a normalizing process, and if I cool it in a water, then it we call it as a hardening process. Okay, so see, we will go to the definition. It is an operation. It may be a heating, cooling, or holding, or combination of operations like heating plus holding plus cooling involving heating and cooling of a metal or alloy. We can heat any metal or alloy, means we can heat any steel, any cast iron, any iron. Okay, if we only heat the iron, it is a metal. If we heat the alloy, it is a steel or cast iron. Okay, just have focus on this thing, that is alloy in a solid state. Means when we heat any material, we must heat before up to its melting point. We cannot cross the melting point, because when you go close to the melting point, the material gets softer and it changes its shape and size. And if we cool it at the same temperature, its size cannot get re-invert. Okay, so heat the material below its melting temperature. So here said what I said, that heating alloy or steel in a solid state. Okay, so heat the material below the melting temperature. For what? To obtain the desirable condition and properties. See, heat treatment is a process to obtain desirable conditions and desirable properties, such like, see here, it gives desirable conditions like it can relieve the internal stresses. See, when we hammer the material, when we hammer the material, it produces stress inside the material, and those stresses are the one who produces the crack in material. Okay, so if we relieve the internal stresses, it will increase the life of the material. Okay, and next it gives the desirable properties, like it will increase the machinability, it will improve the ductility, and it will have the homogeneous structure. These are the output of the heat treatment processes, some desirable condition and some desirable properties. So the heat treatment process is nothing but it is a combination of the three things. We must heat something, we hold something, and we cool something. Okay, so this is heat treatment process. Next we have the classifications. Okay, so we have five types. First, annealing process. Annealing process means if we cool the material in a furnace itself, means we are heating the material in furnace itself and we are cooling the material in that furnace only. So it is annealing process. Next, normalizing process. Cooling the heated material in air. This is normalizing process. Hardening process. Cooling the heated material in water. Means simply we can heat the material in furnace and just put it out and put in a water. It is a fast cooling process. So this is called as a hardening process. Next, tempering process. Tempering process is nothing but it is a process which is done after hardening process, because in hardening process the cooling rate is fast, cooling time is low. It is cooling time is in between just seconds. Okay, just 10 seconds to 20 seconds. So we cannot control the hardness of the material. If the hardness of the material get increased too much, we can again decrease the hardness by the help of tempering process, because the more hardness doesn't mean that it have the good properties. More hardness leads to the brittleness, and brittleness means the material can get failure at a low load. Okay, so if we have the more hardness, we can decrease the hardness of material by the tempering process. That is, tempering process is nothing but we can heat the hardened steel up to some temperature 600 degrees Celsius, and we can cool the material in air so that its hardness can get decreased. Okay, and we can control the hardness. Next, last we have case hardening processes. Case means it is upper part of the material and core means the inner part of the material. So case hardening means we can harden only the surface of the material. We cannot go inside. Okay, so see, in this we have total three types: carburizing process, nitriding process, and cyaniding process. Okay, so this is nothing but the addition of metal on a surface. Just we add the metal on the surface itself, so that hardness of surface get increased. It doesn't deal with the what the core have. Okay, so just we increase the hardness of the surface. Okay, so next, purpose of the heat treatment process. Purpose of the heat treatment process: first, it relieves the internal stresses developed during the cold working, welding, casting, and forging. See, the stresses in material are developed during those processes which have some stress on the material. It may be a forging, it may be a casting, it may be a welding, it may be any a cold working. Okay, so that those stresses developed inside the material are not good for a material or not good for the component. may leads to the failure of component. So we must remove that internal stresses, and that can be easily done by the annealing process. Okay, so annealing process is only for to relieve the internal stresses. Okay, next, harden and strengthen the metals. If we have the bunch of materials which is only the softer ones, okay, so we can change their hardness from the softness to the hardness, or we can improve their hardness by hardening method. Okay, because softer material have the low hardness. Okay, and those metals or those components cannot be used as a cutting tools. If you want to use that material as a cutting tool, then we can increase its hardness. Okay, next, improve the machinability. If we take any material which is a harder one, okay, so that have a minimum machinability or it have the low machinability, so that we can convert that hard material into a soft material with the help of normalizing process or annealing process or tempering process, so that the hardness of the material get decreased and we can have a all machining process on it. So the heat treatment process can improve the machinability. Change the grain size. Grain size is nothing but, as we have studied the iron carbon equilibrium diagram, in that we have seen the perlite process, or you can say the perlite phase. That perlite phase is nothing but the combination of alpha ferrite plus the austenite. Okay, sorry, cementite. So cementite plus alpha ferrite is alternate layer structure. That alternate layer structure have the grain size. If you have the low grain size, it is a good material. If you have the high grain size, it is a more hard material. Okay, so we want the optimum grain size to have a good properties of material. So it can change the grain size also with the help of hardening process and the annealing process. We can change the grain size of the material. Okay, next, soften the metals for further working. Means we can soften the materials. If there is a more hardness in the material, we can soft it with the help of any heat treatment process. Okay, next, improve the ductility and toughness. Ductility means it is nothing but it is a property of material by which we can draw out the wire from a material. Means if you want to draw out the wire on a sheet from a material, means that material must be a softer one. You cannot draw material from the harder materials because it may get cracking in between. Okay, and that crack leads to the failure. So no use. So if you want, that material must have the ductility and toughness, and the if we want to draw the wires, if you want to draw the sheets, it may have the good toughness, then the material must be a softer one. Okay, next, it increases the heat, wear and corrosion resistance of material. Okay, corrosion resistance means it must be a like stainless steel material, so that it cannot get corrode easily in any environmental condition. Next, improve the electrical and magnetic properties. And last, it make the whole structure homogeneous. Homogeneous means the on the material there are so many points. If we check the strength of that material at every point, the strength of the material must be same. Yeah, or if we check the any composition of material at every point, that composition of material will be same. This is called homogeneous, or you can say this is called a uniform. Okay, so the heat treatment process make the whole structure homogeneous or make the whole structure as a uniform. Okay, so these are the purpose of heat treatment processes. Next, we have applications of heat treatment processes. Applications: first, to refine grain structures and to relieve the internal stresses in a rolled and cast steel. Second, to improve the microstructure in carbon steel. Third, improve the homogeneity and uniformity in welded structures. And for steels used in sheet and wire drawing, on casting of carbon and alloy steels, on high carbon tool steels. These are the some applications of the heat treatment process. See, heat treatment process is nothing but a process where we can soften the hard material and where we can increase the hardness of the soft material. We can do vice versa. If there is a soft material, we can hard it. If there is a hard material, we can soft it. Okay. So this is a process where we can change the properties of the material to a optimum range. Okay. So next, this is an overview. What we are going to see in the next 3 or 4 lectures. Okay. So we have total 5 processes. First is the annealing process. As I said earlier, this is a process where we cool the material in furnace. So it is a slow cooling process. Okay. So in that we have total four types: full annealing, isothermal annealing, process annealing, and spheroidizing annealing. These total four types are depend on the temperature at which we are heating the material, their own holding time periods, and their own cooling time periods. Okay, we cool in annealing process, we cool the material in furnace itself, but with the help of furnace we can may add one more step, or we may add more in between step with the air cooling. Okay, so annealing have the four types: full annealing, isothermal, process, and spheroidized annealing. Okay, next we have normalizing process where we cool the material in air. It may be a steady air or flowing air. The property may get changed. Okay, next hardening process. Hardening process means it is a process where we cool the material in water. So it produces the hard material, or it have the high hardness. Next we have tempering process. Tempering process is always done after the hardening process, because in a hardening process we cannot control the hardness of material, because we cannot control the cooling rate of the process, because it is done in between the 10 or 15 seconds only, and because we are cooling it in water and it have the high cooling rate. The cooling process is done in a 10 or 15 seconds only, so we cannot control it easily. So its hardness get increased, and if we want the hardness below than that, then we can go for the tempering process, which can decrease the hardness of the hardened steel. Okay, so it have two types again: Aus tempering and Mar tempering. In Aus tempering we can decrease the hardness, and in Mar tempering we can slightly increase the hardness. Okay, and the last one we will see that carburizing process, case hardening process. Case hardening, case and core are the two things. Case means the upper part of the material and core means the inner part of the material. This is nothing but the case hardening process means we can only hard the upper part of the material. We cannot care about what the core have. Okay, so it has again three types. That is carburizing process, nitriding process, and cyaniding process. Carburizing means, as name suggests, we can add carbon on the surface of the material. Second, nitriding process means we can add nitrogen on the surface of material. And cyaniding means we can add both carbon and nitrogen on the surface of material. So these are the three case hardening processes: carburizing, addition of carbon; nitriding, addition of nitrogen; cyaniding, addition of carbon plus nitrogen. So these are the few types we will going to see in our next lectures. Okay, so thank you one and all.